I would like to introduce Dan Roman. He's a senior software consultant at Menlo Innovations, which is in Ann Arbor. And we're really excited for his talk on AI with Python. So welcome, Dan.
Thank you, sir. Is everyone able to, you guys can hear me and you can see my screen?
Yeah, we can. Yep.
Awesome. All right, let's dive right in. So thank you, Dan. Just for the sake of expounding a little bit, my name is Dan Roman. I am a senior software consultant at a company in Ann Arbor, Michigan called Menlo Innovations. We're a custom software design and development shop. And among other things, we do things like pair programming. That's what I do. I never write a line of code unless I have a pair partner. We also do test-driven development. So we never write production code unless we've got a unit test that fails first. And that'll be a little relevant as we get into the content of the talk today. And I'm a Michigan State grad with a degree in computer science. But what I most certainly am not is a professional data scientist, mathematician, or AI expert. Everything that I'm going to show you guys today is purely the result of amateur enthusiasm. So I will do my best to answer questions as they arise, but we may have to actually ask ChatGPT itself some of your questions as I am not an expert. So with that, let's take a look at what journey we're going to go on today. So I got a couple demos that we'll talk through. One of them is a fairly straightforward one. We'll talk about using the OpenAI Python client and using that to interact with the OpenAI API. We'll talk about text, we'll talk about chat, we'll even try and get some images drawn. I'll talk a little bit about this was actually a bit of a foray in preparing this talk, a foray into the AI world. I used ChatGPT's help as part of making the demo, give you some insight into how that felt. And then we'll talk a little bit about GitHub Copilot. There's a some demos we'll do there using an annual kind of code challenge called Advent of Code. And then after that, I hope to talk a little bit about what's under the hood of AI and talk through an example of one of the most simple, basic AI ML algorithms. So let's dive right in and let's take a look at our live demo. So the live demo, like I said, is fairly straightforward. If anyone has ever interacted with an API or a Python client for Twitter or Spotify or something like that, this should feel kind of familiar. But ultimately, what we have here is cd to OpenAI, and we will run a very basic little client. I've got a request to increase the font size. I see if I know how to do that. We could ask ChatGPT. My friend, I will have to. There we go. Got some zoom in. All right, this is gonna have to suffice for now. We've got a simple little Python client here, and ultimately it's wrapping the OpenAI library. So we run it and we get three little options here. We can chat, we can talk, we can draw, and all three of them are ultimately connected to one very simple call on the OpenAI client that we construct inside of the code. So if we choose the option of chat, get a little prompt, what would we like to chat about? And we can put in something like introduce yourself to the Michigan Python developer group. And then what's happening is that the OpenAI client is making a call out to ChatGPT and giving us back the text content. And that's what we see inside of the console here. It apparently seems to be thinking it's giving me a template for introduction, but who are we to cast aspersions? This is ultimately quite straightforward once we look inside of the source code itself. So we've got our main. I don't want to expose the env values for my secret keys, project IDs, organization, and so forth, and no one else should either. So that's all hidden away inside of an env file. But it is quite as simple as constructing this OpenAI client with those values, and then using that client object to interact with the different functions. So for the example we just saw of using chat, we just use the client chat completion create. We will play the role of user, and then the input that we captured from the console is ultimately the message that we're sending to ChatGPT 5 Turbo. You get to select the model there. So this is very similar to if you were to pull up ChatGPT inside of your browser, you interact with it via text and it'll send you back messages. When you get your response back from that create object, you have to reach into the choices it provides and get the 0th element and print off the content of the message from there. Um, so like I said, fairly straightforward. The rest of the options that we have on the OpenAI client are fairly similar in their use. If we go to talk, what we'll be doing, this is a demo for being able to do talk or text to talk. This one, it's not a prompt. We actually give the text itself. So we might say something like, "Hello world, I am ChatGPT. I am so excited to meet everyone today." And in the same way that the previous call made the OpenAI client call out to the API and give us back our text response. Exact same thing's happening here where our text message is getting sent off into the ether and coming back as an MP3 file. And if we're lucky with no preparation and it's a live demo, you'll be able to hear the result itself. So let us cross our fingers and listen. I hesitate to ask, but was that audible to our friends in the
No, it
no? All right.
didn't come
Well,
across.
trust me, it said, "Hello world, I am ChatGPT, and I'm so excited to meet everyone today." If we'd like, I can commit that up to the repo if your heart's set on having that MP3 file. But like the previous example with the chat create, fairly same one here. We capture the input from the user in the console. We take that input, that becomes the input of the client audio speech create call. We call a specific model, and we get to choose our voice, Alloy. There's other voices available. There's like 6 or 7 or something like that. And then we have to write that response out to a file. And then last but not least, we do the exact same thing with the draw option. So if we call draw, what would you like to draw? I did this before. It was mildly terrifying. Let's find out what this one goes like. Michigan Python developer group. And what this is going to do is slightly different. Instead of giving us the raw image, it's going to give us a hyperlink to an image that's hosted inside of OpenAI. And we will get that back here and brace yourselves. Okay, that's not bad. The one that I saw before looked like a photo and the faces were scary, but here we go. It's the same fundamental concept of taking the input from the terminal and then using the OpenAI client to ship that input off to the API and get your results back.
That's pretty much what we look like here in the room. So
I love it. This is good. Like I said, I didn't save the hyperlink for the old one, which is probably a good thing. So, excellent. All right. So, that by itself, this example will be modified to use Llama 3 or other open source LLMs. I don't think so. So Peter's asking in the chat, can this example be modified to use Llama 3 or other open source LLMs? I don't think so. This is the part where my understanding is not perfect, but I believe that when we're using this Python client for OpenAI, we are limited to the models that OpenAI itself has. So unless Llama 3 is something that is available inside of OpenAI, you won't be able to use that here. It's a good question, though. All right. So if we go back, that was the live demo. Like I said, fairly straightforward. If we've ever interacted with a Twitter API or a Spotify API, it should feel somewhat similar. But like I said, the process of making this demo and this talk was a bit of a foray into the AI world and ChatGPT. So I was using ChatGPT as part of actually making the demo. So one of the big problems that I ran into when I was trying to make the demo was I was running into a 429 response from my requests, which is a rate limit exception, which normally happens when you're sending way too many requests to an API and you're getting kicked off by whoever you're making the call to. And it was very confusing. So I started to talk to ChatGPT about it, give it some questions and try to ideate. And there were some good things and there were some bad things. What I did appreciate was it gave me a very long answer that included a link to a dashboard that I wasn't able to find on my own, a usage dashboard. I was able to get to an account dashboard, but it didn't give me the usage, so that was quite helpful. A little bit of good and bad. It also gave me two images, URLs that were 404s. So, 2 out of 3. But it also was helpful in telling me how to increase the log level to debug, which was great. Uh, Not so great when I was asking ChatGPT for some help, was it was generating code for me on the fly, and interestingly, it was generating code that conflicted with the OpenAI documentation. So in our demo, the example we're looking at, we actually construct an OpenAI client on our own, and we've got our own instance. And the code that was being generated by ChatGPT was using a global instance that's just statically available off of the library itself. And as I was reading through the documentation of the OpenAI API, they were strenuously avoiding that you don't use that. So little interesting, especially so when we consider that's kind of self-referential that ChatGPT is recommending against its own standards. And then, as I'm sure we're all not supposed to do, I just blindly copy pasted the other code that it was generating after I suggested it not use the global client. I paste that into my editor and try and run it, and I start running into exceptions because there are properties on objects that don't exist. Um, so that was not quite so helpful. And for better or for worse, I ultimately ended up abandoning the ChatGPT code and just kind of debugging it on my own. Uh, so interestingly, the core problem of the 429 was I just didn't have a balance on my OpenAI account. So even though I thought I was inside the freemium tier, I had to have a balance. And when I told ChatGPT about that, it was like, of course, you need to have a balance on it, but it wasn't able to tell me that before I got to it. Okay, so that was the demo against the ChatGPT client or the OpenAI client. I want to talk a little bit about GitHub Copilot. So for those who aren't familiar, inside of Visual Studio Code, but I'm certainly sure that you can get this extension on a bunch of other editors. You can install an extension which is basically a live Copilot or AI assistant. And here, this a little bit bigger for remote folks. This is ultimately what it looks like. So if I clear this out, like having just a little chat assistant over here um, has a man page or a help page and has some interesting things. So it can explain code, it can generate tests. We'll talk about that. Ability to fix code, among some other interesting things, including but not limited to, it can look at your terminal. I didn't fully explore all of the options that were available here. I did use explain just because it was the first thing I wanted to run. I was just kind of curious, and it was pretty good for uh, its analysis on the main pie that I had written on my own. It did a great job and reasonably communicated what the intent of it was. It even went so far as to say, "Hey, this is for demo purposes." So that was pretty good. I won't read through all of this, but one of the other functions that it has that I did play around with was tests. That I found very interesting because, like I said, I come from a test-driven development background. So this test file here is actually 100% generated by the GitHub Copilot. And I'll admit, I was actually looking pretty intensely at this for some kind of misstep or a misplace, doing something wrong. But if we just run the test file, they all pass. They run. They can't compile. Python's not in a compiled language, but doesn't generate any exceptions. And I was looking very closely to see where there would be any problems, and I actually couldn't find any. At one point, I was actually looking very, very closely at this line and the assertion that was associated with it, because I thought I had caught the GitHub Copilot in a misstep or a misconfiguration. But after trying to point that out to it inside of uh, the assistant mode here, it actually explained what was going on, and I realized that I was wrong. Um, so that was pretty impressive to me, especially because it's using patches, which for testing is a fairly sophisticated thing that you need to be able to do is mock out collaborators. So all in all, I was pretty impressed by that. Um, see what we've got going on here. Codium is great, GitHub Copilot. Yeah, there we go. So there's other alternatives out there. It looks like Codium is a good one. So that's a good recommendation there. Um, so so that was interesting. I was, like I said, pretty impressed with GitHub Copilot in generating these tests. Um, and my favorite part, because this is what I do at my job, especially if I'm trying to teach a junior developer about what it means to have good tests, is I should be able to come into the code that we're using and basically just change something. And if I run the tests, something should fail. And that's what happened with the test. So, like I said, fairly impressed. All right. So we talked a little bit about GitHub Copilot with the tests. I'll tell you a little bit about what it was like throwing Advent of code at it. So this is, I would say, a shameless plug, but I don't get anything from this. I just think this is cool. But every year in the month of December, um, there's this Advent of code challenge, which is ultimately every day you get a sort of like algorithm or programming challenge, and it comes in two parts. And it's just a story problem. It's lots of fun. I tend to do it with coworkers and friends. But I wanted to see what would happen if I just kind of took one of these prompts and threw it at the GitHub Copilot. Um, and let me. This was some of the code that it generated, and I was incredibly surprised that it worked, and it worked right off the bat. I didn't have to change anything or tweak it. I had to give it a text input file, but I was able to just copy this wholesale from the Advent of Code website, dump it into the editor in its entirety, and it just spat out the code, and it ran without exception and generated the correct answer. Where things got a little rocky was once I went into the day two or the part two. I tried to take this as well and feed it to the Copilot, and it had some trouble. And I didn't go in and Splunk and try and figure out what was going wrong, but it seemed to have a little bit of trouble with that. And let's see how quickly we can do this without it being massively interrupting to the talk. But I wanted to see what would happen if we just try and take the day two, part one. If we just throw this into GitHub Copilot, let's just nuke all of the code that I've got. We just dump this in. Let's see what kind of code it gives us. And then we can run it against the input that I have, hopefully. But we shall see what we shall see. So if we dump this in, that's in day one pi. So I'm going to cd up and then down into the Advent of code. Should have just basically two things. I've got a day one. Huh. All right, so the answer is 8. I don't know that it's worth it. I mean, we could try and ask. I don't, because this code that it's generating is not uh, based on the input that we would be actually running the problem on. So if I come in back to our Visual Studio and we go to our day one input, dump this all in. And then let's see how nice ChatGPT can be, or Copilot can be. Let's see if we can say, can you update the code such that it accepts the input from a file? All right. I will once again admit I am impressed because it was able to recognize that the input is day one input text. So clearly the Copilot has some awareness of not just the open file, but also the rest of the contents of the workspace. So let's try again. All right, so there's our answer, 2716. Let us see what happens. All right, so once again, I have to eat my hat. I will give the benefit of the doubt to GitHub Copilot. That is pretty impressive. So it was able to take that entire input and story problem and generate the appropriate code for it. Given the time that we're at, I won't go through the part two, but that'll be kind of, we'll leave it there with the GitHub Copilot. Um, so someone was pointing out in the chat the open source version. One of the interesting bits with the Copilot is that it's a paid service, so you have to cough up some money. I think it's like $15 or something like that. Um, so um, so that's GitHub Copilot. Before we talk about what's under the hood and get into a little example about a basic classification algorithm, um, I will editorialize a little bit and just say that I have a lot of friends and peers who are very excited about AI and think that it's one of those things that if you're not adapting it or if you're not adopting it, you're kind of a piece of a bygone age. I personally have not yet reached that point in my career, in as much as I have a human pair partner every day. And in some ways, I find it some of the most productive conversations I have are with a pair partner who is able to say, I don't know, or who's able to kind of like riff on an idea rather than just continually give out um, what are thought of as the right ideas. But your mileage may vary. That's just, especially my own experience coming off of a fully paired environment. Um, so with that, let's talk a little bit about what's under the hood, because I think that it would be uh, inappropriate to talk about AI and all of the interesting things that it does without talking about what's actually sitting beneath that. Because I think that there's a misconception that there's some some magic or something really really new sitting under the hood. But the reality is that underneath any AI that you're interacting with is math. It's a lot of math. I was talking to a coworker yesterday who she went to the University of Michigan and took a um, artificial intelligence course. And she told me that her first day, the professor addressed the class and said, if you're here because you want to learn anything about programming or writing code or anything like that, um, now's a good time to leave because the rest of the semester we'll be talking about math. Um, and based again on my amateur and limited knowledge, that is pretty true. Under the hood of AI, where we've got some pretty high level mathematical concepts like linear algebra, calculus, statistics, optimization, graph theory, and algorithm tuning. So while it seems fairly simple when we go and interact with ChatGPT and give it a prompt, the fact that it's able to return a coherent not only sentence but essays is actually pretty impressive. Um, so with that, I wanted to just give a little bit of an exposure to one of the simplest algorithms that are out there and is often used as kind of like an entry level algorithm that's talked about for AI and machine learning. Um, so I want to talk about this algorithm called KNearest neighbors. So it's a fairly straightforward one. It's a classification algorithm. So when we say classification algorithm, it's an algorithm that will tell you whether or not a certain thing fits into a particular category or not. So the very, very basic rudimentary example you can see on the screen here. Let me see if I can zoom in for the remote folks. Of course, 150 is so much closer. There we go. So if we imagine this simple example here, K-nearest neighbors is actually fairly intuitive when we imagine it visually. So if we imagine we've got two different classes of things, we've got our yellow triangles that are facing up and our purple triangles that are facing down. K-nearest neighbors is something that's going to help us figure out what is this green X. If we don't know, if we know it's going to be one of these two classes, K-nearest neighbors helps us figure out which one it is. And it does so very straightforward. It ultimately looks at a set number of neighbors that's K. So in this example, I've drawn a circle around the three nearest neighbors. That'd be K is three. And the algorithm basically just says, okay, well, these are the three nearest neighbors to this data point. Um, and these two neighbors are the blue downward facing triangles. So it's a pretty good bet. The classification then of this green X is a downward facing triangle. So that's all it is. It's like I said, a fairly straightforward um, classification algorithm. And go back to a better resolution. Um, and that's it. So K represents how many neighbors you're going to look at, and then the nearest neighbors are it's exactly that. You have to go and look at the closest data points to the element that you're interested in classifying. So the algorithm for this is actually pretty straightforward in a visual way. You have to calculate the distance. So if you're looking at a particular element and you want to know what it is, you have to go and calculate the distance to every other data point in the data set. We talk a little bit about this at the end, but that does mean that one of the trade-offs of the k-nearest neighbors algorithm is performance. As your data set gets bigger and bigger and bigger and bigger, or if you're going beyond the 2 or 3D vector space and you're getting into a larger n-dimensional vector, you're going to get more expensive computationally. But at smaller data sets, you're okay. But you have to go and calculate the distance to all of your data points relative to the point you want to classify. You then sort your neighbors in order of distance, and then you select your nearest k neighbors. And then, like I said, based on the classification of those neighbors, that's how you determine the classification of the data point you're looking at. So this is a demo in quotes. I don't really have anything quite so interactive, but hopefully something a little bit more visually interesting than some circles and triangles. If we go to k-nearest neighbors, we run that. I cannot pretend to take credit for this. I shamelessly ripped this off of the internet, but I can at least point to the library that this demo is based off of is sklearn, which comes in with some pre-baked data sets, which is pretty nifty when you want to start doing explorations. It turns out finding good data is a lot harder than you might otherwise think. But this is ultimately a visualization where on the x-axis, we've got the sepal length, which is a measurement of the iris, and then the y-axis is the sepal width. So this is just a 2D vector, a 2D two-dimensional space, and then each of these data points represents one pair of measurements between the sepal length and the sepal width, and each of those dots has a classification. And what I like about these two examples is that you can actually see with the visualization of these kind of larger spaces how k-nearest neighbors work. So if you imagine a data point that's falling inside of this purple area, that's the area in which we would classify the data point as a setosa, and likewise with the yellow and the green. The difference between these two is how the distance factors into the classification of the data point. So on the left-hand side, when we select a data point, the distance is the same regardless of how far away a data point is relative to the point we're trying to classify. Whereas on the right-hand side, this is a weighted k-nearest neighbors classification where the farther away a neighbor is, the less of an impact it has on the classification. So you can see right over here, we've got our little purple data point. He actually would get classified back as a setosa correctly in this example. You can also see that there's a little bit of a green geography over here in contrast to the left one. So that's all we've got for this part of the demo or the talk. This is certainly at the boundary of my knowledge, but ChatGPT wrote this all, which I thought was kind of interesting. But your small k, if you have less neighbors, that can lead to overfitting and capturing noise rather than signal. A large k can lead to underfitting and that you're over smoothing the decision boundary. So apparently the rule of thumb is that for a k-nearest neighbors implementation, you want to choose a k that is equal to the square root of the number of training points in the set, which I didn't know. So I thought that was kind of cool. KNN in practice, talked a little bit about the limitations. You're limited by data. You have to go and iterate through all of your data every time you run. So the larger your data set gets, the more time it's going to take, the more computationally expensive it's going to get. But the advantage is it's simple to understand and implement. So simple that I can explain it to you today. You also don't need to make any assumptions about the data distribution. You express your data points as a vector, and you don't have to know really anything else about it other than the existing classification. And then that final advantage, it handles multi-class classification. So you're not limited to a classification, or you don't really have to change much about the implementation. If you are trying to choose a data point that fits into two buckets, like it could be one or the other, or three, or four, or n. So it just kind of gracefully handles that. I asked ChatGPT about the places in which KNearest Neighbors was used. It gave the kind of high level finance and marketing and healthcare, but it claimed that Netflix was using KNearest Neighbors in the early implementation of the recommendation algorithm. Um, I have a coworker. I checked this with ChatGPT. It didn't believe me, but my coworker believed that in an early day, Spotify would do the same thing, um, which it would do its algorithm of recommendation based off of K-nearest neighbors. I think there's like kind of an interesting thing inside of that, which is like you have to uh, you have to be able to codify um, a genre or a tempo or a any number of things that we as humans might think are kind of more interpretive for a song. You have to capture that in some kind of data format with numbers. But as long as you can do that, K-nearest neighbors actually works pretty well. Um, so that's Kanan in practice. Um, we've got 15 minutes at the end for Q&A. I'll do my best, but before we segue over to that, I'll make these slides available for an appendix. We've got links to Advent of Code, a demo or the source code for all the stuff that we just demoed. This third one here, Neural Networks Explainer, is one of the best videos I've ever seen on the internet explaining neural networks. It's by the YouTube channel 3Blue 1 Brown. It's excellent, and it also has some links to some outdated but still interesting source code. The Cornell Machine Learning Lecture Series. This is where I get some of my knowledge from. They just make it free and public to the world. It's about 40 videos. I've checked the first 10 out. Um, it's very, very good, very interesting. And it's a good supplement. So that way, anytime you're engaged in a conversation about AI in your daily life, you've got a little bit more to refer to. And then on the last two, we've got links to the API documentation for OpenAI and the place that I got the KNN demo source code. But that's all I have. I'll turn it over to the group or back to Dan and Evan for um, the closing bits.
Any questions, anyone?
I see Peter's got one in the chat. Can you tell us more about your pair programming experience? Do you have set protocols for who drives? Can you describe a typical pair programming session? What tools do you use to facilitate pair programming in a remote setting? What best practices would you recommend? How do you handle disagreements? Okay, you're in luck, Peter. I know a lot more about pair programming than I do about AI. So thank you for giving me that question instead of some very deep and nuanced question about the math. Um, I've been a pair programmer at Menlo for 5, almost 6 years. It'll be 6 in December. Um, and it's the only program I've ever done at that company. I did solo programming before that, but um, we don't have a set protocol for who drives. What we will often test-driven development is actually a good way to get that organically, where you write a test that fails, and then you slide the keyboard over to your pair partner, and then they write the production code that makes it pass, and then the keyboard slides back after they've written a failing test. Or it's also very organic between the pair. I guess one thing to clarify with pair programming is that we're not talking about two people sitting next to their own computers working on the same task. It is two people, one keyboard, one mouse. Um, so a typical pair programming session, we like to say a good one is like ping pong. You'll see over the course of a day the keyboard bouncing back and forth between the participants. Another good way to think of it is that each person is contributing about 50% in the pair. For remote pairing, Zoom is about it. We will get on Zoom so that way we can see each other. And then we have a tool called Screen Connect, which allows two people to remote into the same machine. And then we just stay on, like I said, Zoom and video meets for the duration. And then what tools do you use? What practice would you make teams new to pair programming? Practices to recommend for teams new to pair programming is start small. It's a skill. It's not as simple as you sit next to someone and start doing work. Um, Starting small is a big part of that. So I've seen organizations that are pretty successful when they say, all right, Friday afternoon, we're going to do the pairing experiment. And we're going to say everyone gets 4 hours, you pair up, and you go work on a ticket that you would ordinarily be working on by yourself, but you do it with a pair partner. And the reason for that is related to your last part of your question is how do you handle disagreements? Is because that is itself a skill. It's pairing is about compromise and it's about the pair having a shared goal. And pairing will not work if you've got one person jockeying to be like in control or being right, or trying to always have the keyboard because they think their idea is the best. Um, in terms of handling disagreements, this is a much larger conversation, and I can share some links to some tours and content for the place that I work. But ultimately, that's something that we as a team handle. We are we are a 100% in-person workforce, and all teams work together in the same office. So if I'm sitting with my pair partner and the pair partner next to us is really starting to go at it in a way we can tell is unproductive, the responsibility is on the rest of the team to go and help with that. But that is the fastest explanation I could give to your very, very good questions. That's right. Evan can recommend doing the tour of Menlo because he has been there.
Thanks very much. I was coming at this from the aspect of a high school teacher, how to incorporate it into high school classes, computer science classes.
Totally.
Yeah, thank you.
You bet.
Hey Dan,
Mhm.
I have a question. I've never used GitHub Copilot. I have used the paid version of ChatGPT a lot.
Mhm.
I'm a beginner, sort of, but I made one real project that helps me. It seems, have you used it a lot? It seems like you were more impressed with Copilot than you were ChatGPT
Um,
for the
yes.
code.
Yep, definitely for the code. I have played around with ChatGPT more like for fun, like, just kind of um like writing fictional stories and stuff like that, and it being kind of interactive was pretty cool. But in terms of coding, it was GitHub Copilot, and especially just within the demo, the code that ChatGPT was generating me was pretty mid. Like it wasn't very good. It was missing things, but it's like you saw with the Copilot, I could give it a pretty big prompt, and it gave me like perfectly working source code for it. So for me, I was more impressed with Copilot than I was ChatGPT.
Yeah, I think I'm going to give it a try. It also looks really helpful that it's right in your VS Code, so you're
Mhm.
not flipping back and forth between your Chrome browser and your back to your code and copy paste. So, thanks for the
Yep,
talk, though. It was a great talk.
you bet. I'm glad.
We got to give you at least one in the weeds question about AI stuff, right, Dan?
Give it a
Uh,
shot.
I was going to ask if there's any comparison at all to be made between K-nearest neighbors and like natural language processing, where you're vectorizing a word and trying to predict what the next most likely word is going to be.
Uh, I don't know. I'm not even going to pretend to pull an answer out of the air. I can say that I once went to a talk about natural language processing, and I can imagine that yeah, there's probably some interesting overlap between K-nearest neighbors and some of the heavy duty stuff that's going on in NLP. But NLP contains classification, but classification by itself is not NLP, right? And an interesting difference, or at least a big, big difference in complexity is um, classification is just this thing is or is not a part of this category, whereas NLP is, again, as an amateur understands it, um, basically generating a token, in this case a word, and then computing what's the most likely next token to come in after that. So it's a bit higher, a lot higher sophistication, but I could not begin to tell you more detail than that. We could ask ChatGPT.
Thanks.
Yeah, you bet.
Any other questions, anyone?